And Leslie, just a little coordinated instructions. Do you want me to do introductory comments and introduce you and Tim, or do you want to just take it from the beginning?
Whatever is easiest. I figured you would maybe start.
Yeah.
And either do you want to say like this is not about closing the transfer station, because I had someone call.
Yeah, we've had a couple of calls about that. Yep.
Yeah.
So I will address that. Thank you. Okay, so I'll kick it off here in about 1 minute.
Hey, Les, I can do the screen share on those figures.
Okay, great.
And were you able to pull up a site map, an aerial map of the site in the area?
I just, while I'm doing the timeline, I think it'll be hard for me to try to read from my timeline and screen share without.
Sure, because I've got a Google Earth figure ready to go if we just want to do
Okay. Yeah, we can use that.
Let's give it 1 more second here. Okay, I've got 5:33, so why don't we go ahead and get started? We can do introductions first. So my name is Chuck Stevens. I'm the county manager for La Plata County, and I'd like to thank everyone for attending tonight. And why don't we start with doing some introductions? Leslie, why don't you go, and then Ted, and then we'll go to Tim.
Hi, I'm Leslie Jacoby. I'm the environmental specialist with Plata County.
My name is Tim Shangraw. I'm an engineer with Engineering Management Support, Inc., and have been working with La Plata County since about 2010 on the Bayfield Landfill.
Ted.
Should I?
Go ahead, Ted.
I'm Ted Holting. I'm the Public and Governmental Affairs Manager for La Plata County. I'll be rather silent this evening, but I'll be listening intently.
Okay, and then the other folks that you may see on your screen, we have Liz Duvay is moderating our Zoom session this evening. And then we've got a timer in the event that we need it, but it doesn't look like we have a lot of folks. So when we get to the question and answer period, I don't know that we'll use the timer. We would just ask people to be respectful and maybe take, 3 or 4 minutes to ask your question if you have any. And we'll just try to keep things moving along that way. If we do have more people join us and it does look like we're going to get more people and a lot more comment, we might use the timer. But for now, Liz, let's just hold off on the timer. I think what we're going to do tonight is start with an informational session about a little bit of the history, the chronology of what's occurred out at the landfill and the steps that the county has taken to mitigate it and ensure that that the landfill is safe and is not impacting anyone's drinking water. I think that's the question that's on everyone's mind. So I think we're going to address that tonight. And then for those of you, we have been getting a lot of questions tonight, or rather this week, about tonight's meeting. This has nothing to do with the Bayfield transfer station. The Bayfield transfer station is operational and will remain operational. This is not about changing any of the services on the Bayfield transfer station. This is about the closed Bayfield landfill and the vinyl chloride that is a byproduct of the landfill after its closing. So if you're here to comment about the Bayfield transfer station, there are no plans to change the operational construct of the Bayfield transfer station at all at this time, and we are not discussing that tonight. So with that, Leslie, how about I kick it over to you and we will go from there.
Great, thanks, Chuck. We're going to share screen and show a figure so we can look at the wells as we discuss them. It's a little easier to have a map in front of you. Tim, could you show the map?
So
Screen share.
So this is a Google Earth map of the area, and I'll zoom it out so we can see what we're talking about here. Leslie, tell me if you want to zoom in and zoom out, and I will do so.
Okay, great. So just a little history, a brief timeline on this site. It was in operation around the 1950s, and it was basically a dump. It wasn't an engineered landfill, and it was a local landowner that was dumping trash in the arroyo. And in the 1970s, the county took this over from the landowner. And in 1986, 4 wells were drilled and installed and sampled. They were groundwater wells. And let's see, do you want to circle where MW1, MW2?
So I have another figure I can bring up that shows those.
Okay.
Okay, hang with me for a second. Do I need to close this first to get into another one?
I think so.
Yeah, okay.
Or just minimize.
Stop share. I'll go into, here we go. Okay, go ahead. So MW1 is here,
So,
MW2 and MW3, those 3.
and MW4.
And MW4 is right here.
And
Okay.
88 South Ridge was also sampled that year.
88 South Ridge is down here. Can you see my cursor okay?
Yeah.
Okay, good.
In 1994, the county closed and capped the old dump. And then in 2000, and sampling continued. At first it was quarterly, and then it turned into twice a year. So in 2002, we added 24 South Ridge to the list of wells that we were sampling. And in 2004, we began to sample for VOCs and found vinyl chloride in MW. Let's see, which one was that?
MW
I know, I'm trying to remember which one.
Sure.
Oops. Okay, so in 2005, the county did some cap improvements to try and start helping to keep more water from infiltrating the cap. They didn't want to add any more water. So we did a lot of erosion control and stormwater management. Also in 2005, we started sampling the Purdy well, 193 trade winds, 61 South Ridge, and 149 South Ridge.
Those are these wells here.
You know, I don't know if they're on this map at all, actually.
Okay.
And in 2006, we drilled and sampled MW5, MW6, MW7, and also continued sampling 193 trade winds, 61 South Ridge, 149 South Ridge, including the MW1 through 4, plus 88 South Ridge and 24 South Ridge. In 2007, we installed another well, MW8, and sampled that one, along with 193 trade winds, 61 South Ridge, 149 South Ridge, and then a regular suite of MW1 through now MW8, 24 South Ridge, 88 South Ridge, and the Purdy well. In 2008, we did additional cap repairs with erosion control and drainage. We were trying to manage some low spots that were causing ponding, and we did some seeding on the cap. In 2010, we drilled and installed PDW1, PDW2, and PDW3, and these were plume definition wells. And then between 2010 and 2012, we started to work with EMSI, and they began working to engineer a leachate management plan, and we also updated the groundwater management plan. In 2012, we installed a passive system of 15 wells, and in 2014, we added 7 more wells to this passive system, and we continued to monitor the plume. And in 2017, we installed an air sparge system. And in 2020, we did some operation and maintenance and upgraded the pump system and continued monitoring the plume. And in 2021, we have some soil gas monitoring scheduled for work. We just got delayed with the rain. So that's just a brief little history and timeline of all the work that the county has done at this closed landfill.
Leslie, if I could jump in real quick.
Yes.
So can you just address the fact that there were instructions about how the landfill was closed and the county, was compliant with those instructions? And maybe even when the landfill closed, what the instructions were, just a little bit. You gave a great chronology of what we've done, but maybe just a little more narrative context around, what's going on out there. And I would ask, the first time we say something like VOC, define it for everyone, please.
Yes.
You guys, the engineers, you've got your own language. So for the rest of us, just define those terms the first time out, please.
So VOC is volatile organic compounds, and that includes vinyl chloride. The landfill that time in 1994, the county worked with Fox Consultants, and they produced a closure plan that was accepted by CDPHE, and that required, looking at the hydrology, looking at the geology, looking at the soils, figuring out how much soil was needed for final closure. Also a long-term management plan of groundwater testing and what it was going to be sampled and the location of these wells. And this was all done, with CDPHE approval. And so that work started in 1994.
Perfect, thank you.
Yes.
And so are we going to Tim from here?
Yes.
Okay, thank you, Leslie. So let me back up a little bit and kind of give you a crow's view of the site, flying at about 20,000 feet. But the site basically is located in a low lying, basically a drainage area here. And the hydrogeology, the regional hydrogeology or groundwater systems that we're talking about today, the system is basically a shallow alluvial groundwater system. And by that I mean it's the aquifer is comprised of silts, clays, sands, and weathered bedrock. So that system sits on top of unweathered shale. So the groundwater in that system starts at about 20 feet below ground, and it extends down to about 100 feet below ground. So we're looking at a 20 to 100 foot saturated thickness of groundwater. And the groundwater in this system typically moves in a similar direction to that of surface water. So if you look at a big map here, you can see the hills here are basically shaded or green with trees, similar on both sides. And then the flat land down below is kind of the brown area. And then we have this dry creek drainage basin that basically drains surface water out of this basin. Groundwater flows, I say, in the very similar direction to surface water. So regionally, groundwater will flow from this high area here, kind of through the Bayfield Landfill area, and then recharge the alluvium beneath Dry Creek. Similarly, groundwater will flow from this high area and flow down toward the creek. So we don't see, so regionally we don't have a cross migration, if you will, of groundwater coming from this side to go to that side. Basically groundwater from this side, groundwater from that side, groundwater from up here, groundwater from over here, converges into the alluvium underneath the creek bed and basically follows the creek bed. So that's how the groundwater system works that we're going to focus on. The next couple of slides, I want to blow up, and I've kind of already done that with that slide I just showed Leslie. But we're going to talk about the groundwater occurrence and the groundwater quality in this area here. So hang with me. I'll try not to drop anything. And with that, we'll go right to that slide. So when engineering management, EMSI, first got involved with this project, this is 2010, the plume was recognized as being limited pretty much in size to this boundary here. So let me kind of explain. What we investigated was A, where's the groundwater, and B, what does it look like? You know, where, and C, if it's contaminated, where is that contamination coming from? So to answer the first question, groundwater beneath the landfill, as I mentioned before, occurs 20 to 30 feet, say, below the ground surface. It migrates toward the dry creek area. And these blue lines are contour lines, similar to you see in a topographic map. But this is a contour of the top of the groundwater table. And groundwater flows perpendicular to that contour, similar to looking at, you know, what a downhill direction on a topographic map would be. So it's not a big surprise that we're seeing the plume of vinyl chloride really concentrated on this area here, immediately down gradient from the deepest part of the landfill, which occurs pretty much in this area here. And what we discovered was that the contaminant of concern is, as we mentioned, as Leslie mentioned, vinyl chloride. It does not, vinyl chloride is a volatile organic compound that is a gas. And when gas comes in contact with groundwater, it will contaminate the groundwater. So that's why it's volatile. It's easy to get into the groundwater. And in this case, it's easy to get out of the groundwater if you sparge the groundwater. What we also found was that we didn't see indications of other compounds that oftentimes are associated with landfill leachate, such as heavy metals or heavy organics. So that also led us to believe that the source of the vinyl chloride in the groundwater is the gas that's generated from the decomposition of waste materials in the landfill. So our strategy to deal with this was really twofold. One, try to eliminate the source to the extent you can. And that involved removing the vinyl chloride gas, if you will, from the landfill. And then secondly, is to the extent that we still have a residual plume, groundwater plume, then target a sparge system / vapor extraction system, where you actually go into the groundwater and you blow air into it, or basically sparge air into the groundwater. And that in turn drives the volatile organic, in this case VC, out of the groundwater into the headspace above the water table. Then with a vacuum extraction blower, kind of like a radon extraction blower that people have in their homes, use that type of technology to remove the gases out of the well. So the first step then was, as Leslie indicated, to install vapor extraction wells within the landfill. So in 2012, we installed 15 gas wells, and they're numbered BL1 through BL15. This figure actually shows the addition of the additional 7. They're up to 24. But the first 15 were installed in the landfill in 2012. And those gas wells are basically pipes that are drilled into the landfill, that are perforated. They go to the top of the water table. They're not really designed to be water wells, so they're just gas wells. And on the top of each of these gas wells, we install a wind turbine. Those are the types of turbines you see on the top of, say, restaurants or whatever. But they work really well when the wind blows. They induce vacuum, and it basically sucks out vapors. So for those who are familiar with the landfill or have driven down Route 223, you see the whirlwinds on the top of these wells. That's why they're there. So for a couple of years, we ran just those first 15, and we saw some improvement in the plume, basically reduction in the off-gas plume, the off-site plume size. But we felt, we could probably do better by adding more extraction wells, gas extraction wells, in the body of the gas source, which was pretty much coincident with, the groundwater plume backed up into the landfill. So BLs 16 through BL 24 were installed at that time. So this is what the plume then looked like before we started, basically in October 2014, right after we installed the additional 4 wells. So we monitored that for several years. And then in 2017, we noticed that we were seeing a nice reduction and the size of the plume. So kind of bouncing back and forth between these two figures, we didn't have enough data to feel confident that we could close this loop here. And again, this loop is the delineated extent of the VC plume above the performance standard. So I'll go back to what we saw in 2017. We felt we did have enough data to bound that plume, and we saw a reduction in the concentration of the plume. So our concentrations in MW5, say, went from 40 micrograms per liter down to 25 micrograms per liter. Similarly, we saw reductions in PW2 and PW3, and MW1 dropped down to less than the performance standard. In this case, this concentration was 1.5 micrograms per liter. In all cases, we always notice that the private wells outside of the plume were either below detection limits, the method detection limit. Well, in this case, they weren't sampled because these data were from semi-annual sampling, and these data here are from annual sampling. But we never saw, up to this point, really, even a detection of vinyl chloride in any of these three wells. So we continue to run that. Well, actually, in 2017, we looked at the data and we said, okay, now how long is it going to take to really bring these wells into compliance using just the passive gas extraction wells? And Plata County made a business decision to say, you know, let's step it up. Let's be a little more aggressive toward remediating the groundwater itself coming through this plume. So in 2017, we designed a groundwater remediation system that consisted of 4 wells, and we call them air sparge vapor extraction wells. That's what the ASVE stands for. And we installed those right in the pathway of what we consider to be the highest concentration of the plume. And those wells basically are a combination of sparging. So we're injecting air into the groundwater, letting the volatiles sparge out, and the vapor extraction blower, if you will, to remove the vapor gas from the headspace. And so then in 2018, a year later, look what happened to the plume. It really shrunk. The aerial and the width and the length of the plume considerably shrunk, and the magnitude of the plume shrunk. So in this case, MW5 dropped down to 2.3 micrograms per liter. We were below performance standards in PW3. The only one that also had slightly above performance standards, other one was this PW3. I'll blow it up so you can see it. So that was at 5 micrograms per liter. So I thought, this technology is working well. It's the right technology for the site. So in the winter of 2018, we encountered some mechanical difficulties with the blowers. I think we had some leaks in pipes. It's a pretty cold winter, and as a result, we weren't able to operate the system full time. Well, what happened is in later on in 2019, the concentrations rebounded. We had a plume migration back out into the same configuration. And then, so that summer, 2019 summer, we upgraded the system. We put in larger blowers, larger compressors, better seals on our pipes, and we've been running it that way ever since. And then in 2020, May of 2020, again, we saw the plume start shrinking back again. And it was interesting to see that the nose of the plume, if you will, had come back quite a bit. But the width of the plume seemed to have extended further to the south. As you know, if you look at these two figures, you can see what I'm talking about. To the point where MW1 was now starting to exceed the standard. So we continued to run that, with the upgraded blower and so on. And last year, October 2020, you can see how the concentrations came way down to the point where even MW5 was only at 5.8 micrograms per liter, barely exceeded the standard PW2 at 2.5, and we were less than the standard everywhere else. but we still had this, what appeared to be this kind of widening of the plume to the south. This spring in May, we had a rebound, and we're trying to figure out at this point why that happened. We know that the sparge system was working well, but what we suspect is we had a very wet winter. The water table may have come up. We may have had more migration of contaminated groundwater, flux, if you will, of contaminated groundwater moving through this system than the original system, was designed for. And/or there was a lot of residual moisture in the soils, which will inhibit the ability for gas or clean air to migrate through the soils. So that basically would also inhibit the effectiveness of that technology. So we're working right now to look at whether this is a seasonal, change or interference with high moisture in the soil. So we're collecting more data to assess that. But we're also concerned that we have this what appears to be this widening of the plume in this area. And so to address that, as Leslie indicated, we're conducting a soil gas survey between this well here, ASVE4, and MW1 to see if we have a gas excursion that might be coming from the landfill that might be interacting with groundwater, and/or if it's if it's groundwater itself that's contaminated, we can assess that with the soil gas survey as well. So our plan is to actually conduct this survey on September 9th. That's the latest as of today. Then we will evaluate the data. And by the way, the gas samples that will be collected from the soil samples for each of these 6 wells will be collected from 5, 10, 15, and 20 feet deep. So we'll be able to look at the vertical distribution of the gases as well as the lateral distribution of the gases between that point and that point. And that'll give us a good 2-dimensional picture, well, really 3-dimensional picture of the gas profile between here and here. Gives us a better feel for how we can approach the most cost-effective remediation system to minimize the potential in future excursion of gas or VC in this vicinity here. So time-wise, we should have results back from that survey mid to late September. We'll be evaluating those results plus the additional groundwater quality results during 3rd and 4th quarter of this year. And to the extent that we need to add more wells and the type of wells, we'll evaluate that during the winter, and then probably, Leslie, I think we're on the same page with this, maybe install the additional equipment next year. So the take home on all of this is that La Plata has been very aggressive in addressing the offsite contamination plume. The real good news is that we don't believe that the extent of the vinyl chloride plume extends much further than what we've talked about with this black dotted line. We are not seeing negative impacts to private wells adjacent to the landfill. None of these wells have ever exceeded a performance standard. We're moving forward, with a reasonably most cost-effective program as we can. So with that, I will be happy to answer any questions.
Tim, this is Chuck. Before we open it up to the public,
Sure.
is there another view where we can maybe zoom out and then see where the residential water wells are, or at least the houses, just so we can get a feel for how close the plume is to any drinking water wells?
Sure.
Thank you.
So here's the site. We've already talked about the South Ridge wells 44 and 88 here, and then the Purdy well is right about here. Leslie, maybe you can point to where other wells might be located. I can zoom out here.
You know, I could share my screen because I actually have the water wells up if we wanted to do that.
Sure, I can, yeah, just, I'll take a stop share here.
Okay. Okay, so here is landfill. And here is 24 South Ridge. This is 88 South Ridge.
Leslie.
It has a well house. I'm gonna
Leslie.
You're not coming through yet. Hang
Yeah.
on. let it load.
There you go, okay.
There you go. And Leslie, you might want to turn your video off just so you get better bandwidth.
Okay. Let me- It's not fighting with it. There we go. Okay. All right, we'll try this again. So here is the closed landfill, and across the street, this is the shooting well, and this is the lot of that, and there's no residential houses on this lot. This is 24 South Ridge, and this one is 88 South Ridge. And so all of these are private wells that go through here. And then we have trade winds. So that's 210, I think. I'm not gonna get it. This is 193. So this was one of the ones that was sampled from 2005 to 2007. This is the 61 South Ridge that was also sampled. And this is the 149. So we started sampling pretty well, 24 South Ridge, 88 South Ridge. We sampled this property, and this property for 3 years. And vinyl chloride has never been seen in any of these. And it's been below the standard in this well, and it's only shown up, I don't know, a couple of times. These are the neighborhoods around. And then we also have over here, this sits, you know, up above, so it's pretty high up, and we don't sample any of these wells because this is kind of the top of the ridge, really right here. So, and then here's 160. So this gives you an idea, you know, this Arroyo started this way and headed this way, and the trash was filled up here and all the way. And I believe the original entrance was this property here. You can see an old access, and there's a gate.
Leslie, I'm not sure that that's showing on your cursor.
Oh. Right in here. Is it?
Yeah, I don't think that's.
Yeah, Leslie, there's a lot of lag time when you're moving the GIS. So
Oh, okay. All right. So let me just, the 88 South Ridge was the original entrance into the landfill. So that's probably why that one was had the first house and was developed with a well.
But north of that, Les. There you go.
Yeah, this one. So, okay. But that shows where all the wells are and around the landfill.
all right, perfect. Thank you. And okay, so if there's no more prepared comments from the staff, Liz, do you want to guide people through how we're going to handle public comment tonight?
Sure, definitely. For those of you who are on Zoom, if you would like to ask questions or make comments, you may do so by clicking on the raise your hand icon that can be found at the bottom of your screen. And as the moderator, I will call on each person who has raised their hand in the order in which they have raised their hand. If you are participating by telephone, you will need to press *9 to raise your hand. So please be listening and on the lookout for your name or the last 4 digits of your phone number to let you know that it's your turn to speak. And please also identify yourself for the record. And I will give you a moment to find those raise your hand buttons. I do have Dale who would like to speak. So Dale, I will go ahead and let you talk now.
Okay, can you hear me?
We can.
Okay, good. My name is Dale Ruggles. My parents live on the corner of Dry Creek Road and 223. Actually, it's not actually the corner, but the first house as you head up 223. And their net well has never been tested. And something you guys have definitely tiptoed around is you're not testing any of the wells in the drainage. You test them up higher and not even towards the direction of the plume. I mean, it's obvious, just your own presentation. Look where you said you tested the wells. They're uphill. And it counter to what Tim said, that, you know, the underground water follows the terrain, and that's exactly true. I learned that years ago at a processing facility I used to manage. We had a similar issue. So all them wells along Dry Creek, all the way until Dry Creek crosses across 223 need to be tested. If they're not, you're not trying to protect the people. So I want to make that statement. But I have some questions about what Tim said. He had a really nice presentation there about some of the mitigation measures that you guys put in. And you specifically mentioned an air sparge vapor extraction wells. Is that right? Is that what you call them?
Correct.
So that is, you're pumping air through a tube down in the ground, and on the casing side, you're pulling back out. Is that right? Is that how that works?
So the sparge tube goes into the water within the limits of the well itself. So it's all within the same casing.
Right, but I mean, you have two pipes, one inside the casing, and your vapor extraction is on the casing side, and your injections on the tubing side. Be just like a gas well. Well, it'd flow opposite of a gas well, but so my question is, do you have any maintenance records on that stuff? And see if it's still performing to factory specifications?
Yeah, we have, it's something I designed, and it's kind of standard procedure for a sparge well and a vapor extraction system.
Right.
Excuse me. So we monitor back pressure on the injected air right at the compressor. Each well has its own compressor.
Right.
So we are able to monitor that every minute, 24/7. So if we start seeing, say, a buildup in pressure that's maybe inconsistent with say a rise in water table, we would say, you know, we got a clog, or we've got something that's wrong. Then we can go back and we can pull that pipe and service it.
So when you say you monitor pressure, that's one thing. What I'm asking is, are you monitoring the volume you're extracting?
No, we're just venting that to the atmosphere.
Oh, so you're just venting it.
Correct.
Okay, so there's on top of the pipe there, what are those? Looks like you got some kind of a power blower or some extractor on the floor along the road.
That's correct. Each one of the wells has a radon blower, radon extraction blower on its wellhead.
Right.
So that air is then vented to the atmosphere.
So how do you know that blower is moving the correct amount of volume?
Well, we can feel the air coming out of the well.
That don't tell you nothing.
Yes, it does. It's just as if it's just as if you have a blower.
My lungs,
on the,
if I can blow.
on the top of your radon extraction system.
So you don't have any maintenance records or performance data per se, as you know, you don't have any standards when you put it in versus what it's doing today. That's what I'm asking.
Our measurement of performance, is groundwater quality.
Okay, so you have no maintenance data, and then
No, we maintain it. The systems are inspected frequently, And if there
But
is
You
any,
you don't know what the
if-
performance is because you're not maintaining it, is what I'm asking.
no, that's not true. We're
I know you're
maintaining it.
maintaining.
If there is a reason to believe that the blower's not working, or if there's a reason to believe that we have an increase or a decrease in injection pressure, then we will take measures to fix that.
If you're not checking the volumetric efficiency of your blower and your amperage of your blower, then you're not checking the performance of your blower.
That is correct. We don't need to.
Okay, well, that's your opinion.
That is correct.
You mentioned it, Tim. I do believe maybe it was the other lady. But there was a really wet year or spring this summer, and we've been in a pretty good drought since about 2016. And so I think you in a way said it without saying it, but the drought is also helping you, because you mentioned that the wet spring this year aided some of your results. So overall, the drought is actually helping you, lowering the water table, probably giving you more airspace or whatever, headspace.
Right.
So what's going to happen if we have a real wet winter and a wet spring? Do you have any ideas?
So that's a good question. I mean, first of all, to your point, the drier, the better. And that is absolutely true. If we find that we have a prolonged wet period, then we need to double up on our wells. We just basically need to install more extraction wells, because the radius of influence will decrease.
Okay, so I want to get back to my original statement. Why are you not testing the wells downstream of the plume? I mean, if one of you could bring that map up, so we could look at the one where you can see the plume. You're not testing any of those wells, and that's what's confusing. And that one's fine.
Dale,
test-
let
Go
me
ahead.
ask you. I'm scared.
Sorry.
Go ahead. Go ahead.
You want me to go or are you going to go?
Well, I brought this up to show you that
Right.
the direction of groundwater movement is indicated by the arrow.
Right.
And all these wells are down gradient. So we are monitoring the down gradient extent to the plume.
But I'm talking about the personnel well, the drinking water wells. Almost none of them. There's one or two you did. I think you said in 15 or something. You did down there along Dry Creek, but none of you're not testing any of those other wells, and none of them following your arrow to Dry Creek in the direction the water flows. And that's one of my biggest concerns is, and I know you guys are banking on solution by dilution, but you're not testing those wells. And the test, I can't, for some reason, I can't zoom in here, but all these wells, I guess straight to the, I guess it'd be southwest over there. I mean, what do you expect to see there? I mean, that's going to be a zero when you're.
So I understand your concern.
Okay.
But our position is that if we have defined the limit of contamination here, and we've got the Purdy well down gradient, we also have the South Ridge 24, South Ridge 88 down side to down gradient, and those are clean. We don't need to be sampling wells further down gradient way over here.
Well, if it's your mother and father drinking it, you would have a different opinion. And
No, I wouldn't. No, I wouldn't.
Them other two on South Ridge aren't the direction of your plume.
Well,
Your plume is going right to Dry Creek.
Still, none of the South Ridge wells are down gradient. They're side gradient.
Side gradient. Okay, well, they're not down gradient. I mean, they don't. Your plume is clearly going straight to Dry Creek. I mean, and that's why you guys doing all of this is trying to keep it out of Dry Creek.
No, the groundwater movement is towards South Creek,
Right.
but the plume is defined by this black line. The plume does not extend to Dry Creek.
Well, you haven't seen it down there.
Why would it be down here if we're clean here?
Maybe you're not testing those wells, you don't know. That's why you're testing all them wells. You don't know which exact direction. I'm sure you did somebody did a hydrology study.
That was me. I did the hydrology study, and I
So
can tell
you know the direction of the
and I-
water. Where it's
Dale, please don't interrupt. You're asking a question. I'm trying to respond to it.
you're not.
The direction of groundwater movement is determined by the water wells that we have down gradient from the site.
What?
And we've constructed potentiometric surface maps. And from that, we'd inferred the direction of groundwater movement. So we know the direction of groundwater movement and we know the extent of the plume. So we believe that we do not need to be sampling further down gradient from the down gradient extent of the plume.
Well, what you initially just said is your wells determined the direction of the plume, and I think you didn't mean to say that, but
I did say that. That's exactly what I meant to say.
your wells don't determine the direction of the plume. Your wells identify the direction of the plume.
The wells are used to determine the direction of groundwater movement.
I agree with that.
Which are directly related to the direction of the groundwater plume.
I agree with that. Okay. So the direction of the plume, even by your definition, is towards Dry Creek. That's where you got all your test wells.
That's correct.
And those are low or not showing anything. And you feel that you have got it corralled, let's say, but you're not drinking the water. And those people that are taking their water out of Dry Creek deserve the sampling of all those wells on Dry Creek. I mean, just because your test wells don't show it, don't mean it's not there. And that's my point.
So this is,
I mean, I understand why you did it, how you
so
did it.
Dale,
and that's
Dale,
great.
that
Great job.
conclusion is based on good science. It's based on science that's used in every other groundwater investigation that I've conducted over the last 40 years. There's no reason to believe that there's any difference in the way this groundwater or this plume moves to any of the other plumes that I've investigated.
I agree with your science and how you did it and how you're identifying it. I agree with that. I'm not questioning that. I'm questioning whether you're catching it all and the people down gradient of this stuff is deserve to be ensured that their wells are safe. And La Plata County needs to test those wells to ensure that they're safe. Not that your engineering is wrong. I'm not saying that at all. I'm saying you're making a mistake. You could be missing it. Could be deeper. Could be shallower. It could be going sideways, like you just said. Your plume seems to be getting wider. It could be doing a lot of things, and you put some engineering behind it, but you're still showing the plume going to Dry Creek. So all you're really doing, that plume is still moving.
No,
It's,
so Dale, let me interrupt. Let me just interject right now. Just because the groundwater is moving in that direction does not mean the plume is migrating further than what we've delineated.
okay, I said that wrong. I agree with that. But the pollution, the vinyl chloride or whatever else is coming out of there. And I have a bunch of analysis from a well that I see a disturbing trend on. Did Matt Solka give you guys that data to look at? Where maybe you could explain it?
I'm not familiar with what you're referring to.
Okay, this is for, you got it on the map. 88 South Ridge Circle.
88 South Ridge, this one here.
I don't know. I can't see your map. It's so small on my screen.
I'll blow it up. This one right here.
Wherever 88 South Ridge.
That's
Where's it?
correct. It's right here.
Okay.
Right.
Okay, if you look at those analysis from the when you first started taking them in 2016, your vinyl acetates have gone up like 15%. And you have a bad trend going on there that it's rising.
I'm not familiar with vinyl acetate.
Well, it's on your analysis.
I'm familiar with the vinyl chloride, and the vinyl chloride has never been detected.
What about the vinyl acetate?
Leslie, can you pull that up? Actually, if you're looking at the data, Dale, can you share your screen?
Oh, well, I'm looking at the data on my phone and I don't know if I could do this or not. Let me see. Hold on.
Dale, while you're looking for that, I'm going to suggest that we try to answer this question. If we can get this question about vinyl acetate presented, asked, and answered, then I'd like to open it up to some other folks. We spent a little bit of time with you, which is great. I think this is a good conversation, but I want to make sure that we give everyone an opportunity. If nobody else has a question, then we can certainly circle back to you for a final few minutes. So if you can get the data on the vinyl acetate and get your question asked, we will address it and then try to open it up to some other folks. Thanks.
I'm not even close to being done, but while I'm looking for this, I think you should just take questions.
All right, Liz, you want to open it back up and see if there's other questions? And if there's not, we will let Dale ask a few more. And Dale, if you have extensive questions and conversation that you want to have, we can have those offline because I'm not going to hold it looks like we've got another hand up, Liz. So
We do, yes.
okay, go ahead.
Yes, we do have someone with the Zoom username of Lenovo Smart Tab. I'm not sure what your name is, but I will let you talk. So go ahead. Go ahead and talk now. And I don't see you talking here. Hold on a second here. So you will need to press *6 to unmute yourself. There you go.
Okay, can you hear me now?
You can. Thank you.
Cool. My name is Thomas Jones. I live at 311 Southridge Circle. So the area that they're talking about is a little bit down below from where my establishment is. But we drilled our well, or I should say our well was drilled before we moved in. We moved in 1999. So there's a few things that kind of complicate this situation. We never knew about this landfill and the problems that came. So we're going to be talking to our realtor about that. But the concern is we drilled 240 foot to hit water. So from where we are on 311 to the groundwater level of the road, what are the chances that my well could be contaminated or signs of chemicals in it due to the fact that we had to drill that far?
Let me pull up the figure here. Tom, I appreciate your comment. Let me just pull up the figure and maybe you can direct me to your house.
Yeah, we're up on the top here, 311. Once you get into the Southridge Circle.
Okay.
Go ahead and zoom in a little bit more. Yeah, so we're up on the top a little bit more. There you go.
Right there.
One more house over to, I guess it would be your left or my left.
Right here.
Okay, go to the east then. And then move to, there you go, a little bit further, the next house across the road.
Across the road. Okay.
That one right there, that is 311.
Right.
And this is where we drilled 240 foot to hit water. So what are my guarantees that none of this, like Dale was saying, and I've talked to Dale extensively, I trust the man quite a bit. What are the chances of some of this stuff getting into the water table that is that far down? And why can't the county at least say, and agree with Dale, hey, why don't we check all the wells in this area? There's only like 43 of us out here. So for the minimal cost that it would take to at least check everybody's wells and say, hey, you're good, would be better than anybody getting all out tight and creating civil suits or whatever shit might happen, excuse my French, instead of just doing, hey, let's check these places out to see, because it is in concern. I never knew this was going to go on. So therefore, I'm in a position of going, oh, great, my children's future depends on water from my well. Is it going to be contaminated 10, 15 years down the road? So this wasn't something that I planned on. I was hoping to have, if anything, city water at some point in my life. So having our wells checked is just a common thing that would be smart for everybody. Just check the wells and we can move on with this.
So Tom, I can address your first question, but I'm not sure I can address your second one. The first one is, what is the probability of your well being impacted by the landfill? I would say it's very low, almost extremely low. You're in a different formation to begin with, and your side gradient from the contamination in the landfill. If 44 and 80, 24 and 88 aren't seeing migration in their wells, it's very, very unlikely that you'll be seeing it in your well. So that's a technical response to the first part of your question. I can't address the second part.
Okay, well, at this part, going back to what Dale said, it wouldn't hurt the Plata County to come out and just guarantee this neighborhood. And a lot of these people don't even know about it. And we know, we've done the Southwich Circle community thing and talked to people. A lot of these people don't even know what's going on. So for the county to step up would be helpful in many manners.
So this is Chuck. I'm the county manager, and I think, you know, if you go back and you look at the mitigation that's taken place over more than a decade, the county has absolutely stepped up. As far as testing wells, we've seen absolutely no indication that there's any contamination in this neighborhood. That's not to say that we can't test or that we won't test. I'll certainly take this back to the board and ask them if they would be interested in testing wells. Leslie, I think you sent me some data earlier. What do we think it would cost to get a well tested for? Because if the county were to do well testing, we would only be testing for vinyl chloride. So what would that cost if an individual wanted to go get their well water tested for vinyl chloride?
I did speak with a consultant, and it was about $1,400 a well.
For vinyl chloride?
Yes.
Okay. So, you know, I can certainly take that back to the board and see if they want to go down that road. But right now, we've seen absolutely zero indication that there's any contamination and incredibly little potential for contamination, especially in the formation that we're looking at here on screen. So to say that the county needs to step up, I take issue with that, because I think for more than a decade, the county has done, the county has absolutely stepped up to perform this mitigation and the treatment that's already occurred.
Well, I thank you for your time.
Yeah, I would, Chuck, I'd also add to that we have been in situations like this before, where we had homeowners that are on wells and, you know, request an independent or basically another assessment of their water quality. But I would caution anybody to, before that happens, to look at the integrity of your well, to look at whether or not you have a septic system, and to look at where the location of your septic system is relative to your well. We can talk offline about that.
All right, Liz, you want to go back to public comment, please?
Yes, we do have a couple more people that have raised their hand, and I'm going to go ahead and I'm sorry if I do not get your name right, but Esther Balin, I'm going to go ahead and let you talk now.
Hi, my name's Esther, and I live at 61 Southridge Circle. And from the conversation, it sounded like my property was part of, I guess, some of the original testing. And it seemed like it stopped, or it was just for like a few years. And so one, where would that information be? So we're not the original owners of this property. So I'm not sure, when we bought the home, none of that was really disclosed. Like I didn't get any of that information. So I don't know if is that with the county just to test. And then, you know, I totally get the cost of all the testing of wells and the maintenance around just having good drinking water. And so from what I understand, I mean, I know that Southwest Colorado has all types of minerals and heavy metals in the water. So is there any, like, I know we're talking about vinyl chloride, but I know like some people also have uranium in their water. So what is I mean, so is there like an acceptable level of this? And three, is there also a way, like, it sounds like folks are really kind of being more aware and really interested in taking care of their wells and well maintenance. I mean, so is the county able to partner with us in a way where we can kind of collectively have our wells regular tested at a, you know, nominal fee, some kind of like partnership? Because I am interested in the vinyl chloride, but I'm also interested in like other things that are in my well.
I can jump in, Tim, to start.
Yep.
So the county worked with CDPHE back in 2005 to 2007, and CDPHE is the one that determined the wells that we were going to be sampling for residential. We stopped sampling that location because there was nothing found in the well. We continue to sample the ones that are adjacent to the landfill. We also have 2 wells that are located inside of our fence. Is another, you know, way to check the wells. You know, we are only looking at vinyl chloride. If you have heavy metals in your well, that's not something that, you know, is coming from the landfill, you know, that's could be naturally occurring. So the only thing that shows that it would come from the landfill is vinyl chloride, and that is the only thing that we, you know, would test for.
And I think to Esther's question about acceptable levels, the acceptable level of vinyl chloride is 2 parts per billion. And that's a health-based standard from the CDPHE. Actually, it comes from EPA.
And as far as the, you know, the real estate thing, like, it's not the county's responsibility to provide that information to real estate agents. This landfill was in operation, you know, since the 1950s. It might have even been before that. But that's, you know, that's something that you would have to discuss with your realtor. It's not La Plata County.
But Leslie, we can provide the information. Your first question is where can she find the information? Can you answer that?
Yeah, all of this information was submitted to CDPHE. So they have all of these records.
So remind me, I'm not even familiar with what that acronym is.
It's the Colorado Department of Public Health and Environment, and they have a solid waste division, and they oversee all of the landfills in Colorado.
So Leslie,
Okay.
we can post that information on the website, and we can help people find at least the contact information. If ideally, we can get the information and post it on our website for them, right?
You know, we could provide, you know, the CDPHE link, but for them to, you know, you could do like a, you know, a request with them. But yeah, we could post that.
Okay, and so you referring to them as them, so I'm assuming they're an agency out of Denver?
It's a Colorado state agency, and they do have different offices around the county. I mean, I'm sorry, around the state.
Okay. Yeah, and I didn't mean to sound accusatory regarding the real estate concern, but I think, you know, I mean, I think as a society, and I feel like we're trying to move forward in this idea of, can we just have some transparency and some, you know, neighborly affiliation here? And that's what I was talking about. Was, so like, are there any types of programming, or do we just talk to the county commissioner about like how affordable, like, water testing, like, where is that available? Because I think, you know, a lot of it is just sort of us having to hunt on our own in different areas, which is fine. I mean, if the way they want to keep doing things like that. But I think for somebody who's kind of new to this, it's a little disheartening that there's not like relevant, like helpful information, and maybe I've just talked to the wrong people. So that's really sort of the conversation I was trying to start, not like in returns of like kind of tossing blame. Like I'm not even going there, but I'm just trying to kind of get some clarity and trying to feel out what kind of partners are here for homeowners who live in this area.
Esther, that's a great suggestion, and we will do exactly that. And there's,
Well,
Okay.
there's
it
no
is-
reason why we can't
Well,
get,
water well testing is in part of our comprehensive plan as well. So that information is out there. And if we just need to direct people to that information, we can certainly help.
yeah, we'll clean up the webpage.
Okay.
So we'll get information, we'll help people, we'll do exactly what you suggested. That's a great suggestion, and we will do that.
Okay, thank you.
Okay. We do have one more person that has raised their hand, but I will go through the script one more time for those that may need another reminder. For those of you who are in Zoom, please go ahead and click on the raise your hand icon if you would like to speak. As the moderator, I will call on each person who has raised their hand in the order in which they have raised their hand. And if you are participating by telephone, you will need to press *9 to raise your hand in order to do so. We do have Dale who is asked to speak again, so I will go ahead and mute you, Dale. And you will have to press *6 as well. Dale, I think you need to press *6. It's still not, there you go.
I don't know about *6. How about just press unmute? Well, I have that up, or I did. I can bring them analysis up here, but I don't know how to share my screen with you.
Tim, if you want to stop sharing your screen, I can pull it up.
Sure.
So this is the vinyl acetate from 88 Southridge in 2016, and it is non-detect.
Are you seeing my screen?
This was from your question earlier. This shows the
Yeah.
vinyl acetate at 88 Southridge in 2016, and it was non-detect.
No, it is detectable. That's my point.
So it's showing right here, vinyl acetate is non-detect.
I don't know what you're looking at, but I've got the analysis on my
Okay, well, I'm
screen.
actually looking at the lab data for 88 Southridge for 2016. And you
Okay.
can see vinyl acetate, and under result, it's a non-detect.
Look, oh, I see what you're looking at. Look below that.
So those are just percent recoverables. That's not the result. The result for vinyl acetate is non-detect.
The result from other ones are going up. Toluene, the first and the third one have gone up 15% since 2016.
What's the first and the third one?
I can't even say those. Dichloroethane and debromine fluoroethane. Those are going up. And those are from degradation of landfill type materials.
Can I address that?
Please.
Sure, I would love to hear
Sure.
somebody.
So those are quality control surrogates that are used during the calibration of the gas chromatograph. So those are
And that's
basically,
calibration gas?
those are calibration standards. That's correct. And the recovery is the 94.3%, 108%, 96%. You see over in the right-hand column, this is units. That's percent recovery.
Mhm.
And what is allowable in terms of an acceptable calibration for that instrument is between 170% and 130%. So all this is showing is that the machine is calibrated within the allowable calibration range.
That's a horrible calibration range.
Well, that's the standard.
130?
That's the standard.
Well, we used to run chromatographs and we'd have them way closer than,
Well, that's the range, But look at the result. The result is very close. You're 94 to 108%.
I wasn't comparing them to that. I was comparing from 16 to 20 and the bouncing around that it's done. So if you're saying those are calibration gases, I'll believe you for now, because the way it looks like a type of vinyl acetate,
They're
but
not gases.
well, I think they are.
They're deuterated. They're
gases.
deuterated
They're
standards.
calibration, right?
They're deuterated standards.
Yeah, they're calibration gases. Okay. All right. I'll go with that. But I pointed that out when that lady sent those our direction. And then there was another chemical that shows up every once in a while on these. And I wasn't familiar with it, and I actually didn't do any research on what the chemical was. And it was let's say go to the, if you're looking at them, are you guys seeing my screen where I'm at?
No.
No, I'm sharing my screen.
The broform on 2020, bromoform. Can you tell me what that is?
Give us 1 second, Dale. Leslie, if you can try and find, there you go. If you can try and find that, we will try and answer this question. Okay, so
Oh.
Dale, if you can look and see, are we on the,
Yeah,
are we looking at the same data that you're looking at now?
I can see the bromoform. Dale, I believe that is a trihalometane. That is a breakdown product of chlorination.
Yeah, it's a bromated organic solvent.
True. Can be.
What it says right here on Wikipedia. Colorless liquid at room temperature, high refractive index, high density, sweet odor. To that, a chloroform is one of 4 haloforms. So I'm pretty sure are icky bad stuff. So
It's a trihalometane. It's a breakdown product of chlorination.
I can't tell you what it is. I just seen it in this analysis where it comes and goes. I'll do more research on that.
Okay.
So you guys don't have an online chromatograph checking this? You're doing samples on an annual or semi-annual basis?
Correct.
Is it annual or semi-annual, or what, at what frequency are we taking
Which
Yeah.
wells are you referring to?
any of them?
The 24 and 88 Southridge are sampled on an annual basis based on CDPHE, and the rest of the wells are done twice a year, including the Purdy well.
And the Purdy well is the one downstream of the plume, right across the road.
Correct.
It actually looks like a water well, an actual water well.
It's a water well. It's not a groundwater sampling well.
I wrote another note. So I need to echo what the other people have saying, and the other people, I don't know if they're not talking or what on the phone. I've gotten text messages from people saying they can't get on. And I couldn't get on either off the link that was online. I had to go to the Durango Herald and click the article to get this link to work. So I'm not so certain that the link wasn't broken. I think that you could quiet all of us down with sampling of the wells, especially along the Dry Creek drainage. Yeah, that's what we're asking for. If we don't get that, I can tell you, you will have a class action lawsuit on your hands, which is going to cost you way more than the sampling. And all we're asking for is to make sure that the water in the Dry Creek drainage, and there's probably others that would like to have their wells tested, have them tested for all pollution that comes out of a dump, and I think you mentioned it, latches or whatever those are called, just like the analysis that you were just looking at, we need to have that done for all the ones in the drainage. I mean, it's pretty, and I understand the engineering behind it, and I'm sure it's sound, but I don't think it's the engineering isn't to protect the people. It is to identify the pollution, and that stuff's still there. Just because it's getting diluted out, don't mean it's not there. And I do applaud you for the hundreds of thousands of dollars you put into the mitigation efforts. But you still have a whole bunch of people downstream of that landfill, and you need to protect them. And you never know. If you find I know the reason why you don't want to test them, because if you find one, then you really got a big problem. And then my next question is, I understood that the state wants you to put a processing plant there. So what does that consist of?
I'm not familiar with what the state wants.
How about any of you other people? Chuck?
Yeah, I'm not familiar with what you're asking for either, Dale.
Well, when I talked to Matt Salkley, he said the state wants a processing plant there. And what I understand from the processing plant is you remove all of that landfill and you process it. I'm not sure what processing means, but to me, that would mean digging it up. And to me, that would could create a really large problem for the groundwater downstream of that landfill if you start digging into that. And I bet you Tim,
You don't want to do that. You don't.
well, the is demanded that you guys take care of this, not to put Band-Aids on it. And so is the plan to clean it up. I mean, Matt told me it was a processing plant.
Okay, I'll get with Commissioner Salka. I'm not sure what you're referring to, but I'll talk to him tomorrow and see if I can find out. As far as the county's plan, our plan is to continue doing exactly what we're doing. We have a treatment and a mitigation plan in that is working, and we're seeing the plume shrink. We've had some mechanical failures, and we see the results of that. When we have that, we've seen what happens if we have a wet winter and a high spring melt. So we know how to deal with that, and we're going to adjust our treatment accordingly. So I think the plan right now, I know the plan right now is to continue doing the treatment and mitigation as we have been. And we have no indication right now that any of the drinking water wells are being threatened or at risk. So I will take your question back to the board, and I'll ask and see if the board has an interest in providing testing. I heard Esther's comments, and I completely agree with her. We will get more information out on our website to help people navigate through the bureaucracy. If people need help finding the original test results from CDPH&E, we will absolutely play a role in helping you do that. And other than that, I think we're going to keep doing the mitigation as we have been.
What is the possibility of, them little Home Depot ventilators you got all over the dump that you tout as some magical system, only works when the wind blows? What about putting a powered evacuators on those where they work 24/7? Tim, maybe you could answer that question.
Sure. You're talking about an active landfill gas extraction and treatment system. So that is an option. We looked at that back in 2010, 2012. That would be more effective than a passive whirlybird type system, but at a huge cost. And we ran the numbers, and we were looking at $500 to $1 million to do something like that. For maybe an improved gas extraction efficiency, but we'd still have to deal with the contaminated groundwater that's located downgraded from the site.
Well, if you can, I mean, I totally understand the absorption of the gas and the water.
Mhm.
To me, if you would put mechanical or electrical evacuators instead of the purely mechanical little whirlybirds you got on there, you could do a lot more efficient job of keeping the gas out of the water.
I agree. You're absolutely right, Dale. That
And
would be a much more effective way to do it, but at a huge cost.
Or maybe you could just do one row, like right down the center or, inside the fence and do one row and leave your whirlybirds. And, you had them all marked on that one map. You could draw a line across that whole area and just say, let's just do one row and really pull hard right here.
It really doesn't matter. I mean, as you can imagine, Dale, the infrastructure cost to install a flare and the piping systems and the monitoring programs associated with that are where the costs are. Whether you have one well or 10 wells, the cost of the wells are relatively low. It's the off-gas treatment system that and the operation of that system that runs up the numbers.
So they would make you put an incinerator in or just a flare for the methane?
No, that's exactly what I'm talking about.
An incinerator?
Well, a flare.
A flare.
It sounds like you're familiar with those.
I used to manage $1 billion gas plant. I'm familiar with flares.
You're familiar with flares. There you go. Absolutely.
Flares. We had steamed ours.
And you know what the operational challenges associated with those are.
I totally 100%. We had to put, and this is why I'm so into this. We had 8 parts per million of VOCs coming out of our CO2 vent stack, which was 12 million cubic feet a day.
Mhm.
And they made us put an incinerator on that CO2 vent stack to take out those 8 parts per million. And that incinerator put out like 30,000 tons a day of carbon monoxide.
That's exactly what we'd be facing with that type of a system here. Is now we'll get onto the monitoring system, the emissions monitoring programs from CDPHE, and it's just one thing leads to the next, and the numbers, the costs just keep ramping up for, okay, some improved efficiency, but when you're talking with a limited budget, you have to really question whether it's worth it.
Well, I hate for you to say that because that devalues your intelligence, because we live downstream of this. And we want that, and I don't care if it costs the Plata County $5 or $5 million. The water, and so do them landowners. We want to make sure that our water is good, and that's all we're asking for right now is to ensure us that the water is good. And I know you've done testing and mitigation and all of that, but you haven't tested the wells to ensure all of this. And that's our point. And there's quite a few people that are concerned about it. And this could blow up really big. And, I think if we would just test the wells, we would do okay. And I'm not challenging what you guys have done. I want Chuck, Tim, whoever else is on, I want you to understand that I might have questions. I don't think you do a performance tests on your stuff right and all of that. But the fact of the matter is you guys have done things and it's been engineered. But the one thing you've left out is to ensure the public that their well is safe. That's the one thing you've left out. And
So Dale, I've heard your request. I've got it written down. I'm going to talk to the board. We're going to see what they say, but I got to tell you right now that we have zero indication that there's any contamination beyond the plume, and we've got it defined. But I've heard your ask. I will take it back to the board, and I will get back with you.
And then my last thing that I'll say is, with this processing plant that supposedly we're supposed to put in, how are you going to protect all of those people there when you start digging that landfill up?
Well, again, I have zero, and look, I would know, I'm the budget officer and I control the checkbook. And there is nothing in the budget about any kind of processing plant. So I'll talk to Commissioner Salka and see what he was referring to, but I'm telling you right now, there is no plans to dig up that landfill. We've got the treatment and the mitigation plan that we have. We're happy with it. We like the progress we're making and we are staying steady course.
But the state don't. Why, what the state tell you to do? Are you familiar with?
Well, yeah, I've answered this question for you already. I have no idea what you're referring to when you say the state is telling us to do a processing plant. So
Well, the state would clean it up, right?
what's that?
The state Supreme Court,
Mhm.
after your years and years and years of trying to not do anything, the state Supreme Court told you had to go clean it up.
No, that's not even close, Dale. We've shown you tonight, we've been doing mitigation for more than a decade.
No,
The
what I'm
state
saying.
Supreme Court, the state Supreme Court ruling, that was about discrete legal issues. It had nothing to do with whether or not La Plata was doing mitigation. We've been doing mitigation since, I don't know, Tim, when, 2000 what? I don't
They
even know.
told you to clean it up. I'll get that. If you get me back the answers to my question, I'll have that for you. And you know, the state came, they gave you an order, and that's what this is all about. It made the paper and everything. I mean, the drain,
There was certainly an article in the paper. I don't disagree with that. The Herald does what it does. But the issue wasn't about whether or not La Plata County was doing treatment or not. I mean, the headline of the Herald article was incredibly misleading. We've been doing mitigation of this landfill for more than a decade, and we plan to continue. The issue at the Supreme Court had to do about whether or not the definition of a person included the county. It had nothing to do with whether or not we were doing mitigation and treatment.
that's not what I'm saying at all, Chuck. You're either trying to avoid my question or you don't understand it. So I'll say it again. The state ordered you to clean this landfill up. It had nothing to do with whether you're doing mitigation or not. The state ordered you to clean it up.
Okay, well, I think the state order was, to get the vinyl chloride below the MCL, the maximum containment level. I think that's the order, and I think that's what we're doing. And I think everything that we've seen so far indicates that we're being successful in that, and we're going to continue doing that.
Okay. Fair enough.
Okay, we're at almost 7 o'clock, so let's see if there's anybody else that has a comment or a question, Liz, and then we will wrap up. And I thank everyone again for their time this evening.
Yes, I'll run through the directions really quick here. If anybody is on Zoom and wishing to make comments, please go ahead and click the raise your hand icon at the bottom of your screen. I'll give you a couple moments to look at that and find that raise your hand button. And I am not seeing anybody raise their hand.
Okay, so we'll go ahead and close tonight. Again, thank you everyone for your interest in coming out tonight. We will get more information out on our website. And Tim, thank you very much, not only for your work tonight over this last 90 minutes, but for the work over the last 10 plus years to ensure that the citizens of La Plata County have safe drinking water. Thank you very much.
You're more than welcome. Thank you for letting me participate.
Thanks. All right, let's close it down. Thank you, everyone.